Let's do problem 1. So here we turn this parametric equations into an equation involving x and y. So let's first consider this equation x of t equals 3 cosine 3t plus 6. First, I'm subtracting 6 from both sides. So I get x of t minus 6 and this equals 3 cosine 3t. Now I square both sides. So this becomes x of t minus 6 quantity squared equals 3 cosine 3t quantity squared. So I write down this as x of t minus 6 quantity square, and this equals it is 3 square, which is 9, and cosine 3t square equals cosine square 3t. So first let's consider this as equation 1. Now let's write this equation as y of t plus 1 plus 7 by adding 7 to both sides. And so this equals y of t plus 7 equals 3 sine 3t. Now let's square both sides. And so this becomes y of t plus 7 quantity square. And this equals the square of this is, we should square this as plus we should square sine 3t. So square of 3 is 9 and square of sine 3t we write as sine squared 3t. Let's consider this as equation 2. Now let's add equation and 1 and equation 2. So we have to add the corresponding left sides as well as the right side. The left side of equation 1 is x of t minus 6 quantity square plus the left side of equation 2 is y of t plus 7 quantity square. Now we add the corresponding right sides. So the right side of equation 1 is 9 cosine square 3t plus the right side of equation 2 is 9 sine squared 3t. And now we factor 9 from the left side expression. So we get 9 times of cosine squared 3t plus sine squared 3t. Remember that this expression equals 1 according to the Pythagorean trigonometric identity. That is sine squared x plus cosine squared x equals 1. So therefore we can write down this as 9 times of 1, and this equals 9. So on the left side we have this expression, and since we have removed the t from the expression, we can write x of t as x. So therefore the left side will become x minus 6 quantity square plus y of t, we can replace it as y plus 7 quantity square, and this equals 9. So this is the equation after removing the t or eliminating the t parameter. We now do problem 3. So here we have x of t equals cosine t minus 1. So first I'm going to add 1 to both sides. So I get x of t plus 1, and this equals cosine t. Now let's consider this equation. Y of t equals secant t plus cosine t. I can rewrite this as y of t equals by replacing secant t using the reciprocal identity. Secant t is basically 1 over cosine t plus we put this cosine t. Now in this expression or in this equation, we can replace cosine t as x of t plus 1 as we found from the equation 1. So therefore I can rewrite the second equation y of t, and this equals 1 over cosine t is x of t plus 1. So I put this as x of t plus 1, and also replace this cosine t by x of t plus 1. Now we can write down in the format of x and y by replacing y of t as y and x of t as x. So therefore we will have y equals 1 over x plus 1 plus x plus 1. We can rewrite in simplified form by combining these two fractions. So for the second fraction, I have to multiply and divide by the common denominator, that is x plus 1. And so therefore it becomes 1 over x plus 1 plus we have this x plus 1 times x plus 1 is x plus 1 quantity square divided by the denominator x plus 1. So now we have the common denominator x plus 1, which means we can combine these two fractions and write down this as 1 plus x plus 1 quantity square, and this is over x plus 1. So this is the equation involving x and y after removing the t parameter.